Hello everyone, and welcome back. Today we're learning all about the unit circle and how to get values of sine, cosine, and tangent from points on the circle. Get your notepads and pencils ready for some notes because you might need them to answer the questions throughout the video. Also, there is a worksheet in the description for you to do after the lesson for more practice. Today's lesson talks about degrees and radians as a measurement of angles. So if you aren't familiar with radians, I suggest you go back and watch my lesson about radians before you continue. All right, if you have your paper, pencil, and calculator, then we are ready to begin today's lesson. Before we learn about the values of the unit circle, we need to understand what the unit circle is. Let's watch this short animation and I'll explain. The unit circle is a circle with a radius of 1 unit. The length of 1 as our hypotenuse of the created right triangle allows us to easily compare the trig ratios and values of different angles. Just like with any circle, the circle is 360 degrees around, or 2 pi radians. When we move the radius around the circle, we have a point that we call x and y. If we draw a line from the point to the x-axis, and then back to the origin, we create a right triangle with the angle theta closest to the origin. As we know, the ratio of sine is opposite over hypotenuse. So we can work out to know that sine of theta is equal to the y-coordinate. The ratio of cosine is adjacent over the hypotenuse. So we can work out to know that the cosine of theta is equal to the x-coordinate. And tangent is equal to the opposite side over the adjacent side, which means y over x, or sine over cosine. Now that we know what the unit circle is, and we understand which coordinate value is equal to which trig ratio, let's practice finding the values in quadrant 1. In the first example, we want to find the values of x, y, and the ratio of y over x for points A and B. I've already got them listed here on the quadrant 1 of the unit circle. Point A creates an angle of 37 degrees, and point B creates an angle of 64 degrees. So let's look at A first. Okay, the AX value. What I like to do is just draw a line straight down to the x-axis so I can get a better understanding and a better visual of what the x value is. So let's draw that line straight down here. As we can see, the x value is at about 0.8. Now the y value. For the y, we'll do the same thing. We will draw a straight line over to the y-axis, and that's going to give us a value of about 0.6. So now we want to find the ratio of y over x. Well, we know my y is 0.6, and we know my x is 0.8. We can put that into a calculator, or you can solve it by hand if you'd like, and that'll give you a value of 0.75. So now you try for point B. Pause the video if you need more time. Hopefully, for your x value, you got 0.45. For your y value, you got 0.9. And for your ratio of y over x, you got 2. Do you think you have it down now? Let's look at some angles in the other quadrants and get the values of those points. In example 2, we want to find the values of sine, cosine, and tangent for each of these points. Let's start with point A. Point A has an angle of 114 degrees. So just like in our last example, what I want to do is draw a straight line down to the x-axis and over to the y-axis so we can better see the exact values. So if we go down to the x-axis, we're here, and if we go over to the y-axis, we're about here. So we're at an x value of negative 0.4 and a y value of 0.9. Well, if we remember, from our explanation, y value is the same as our sine value. So sine for angle A is going to equal my y, which is at 0.9. We also remember that our x value is the same as our cosine, which for angle A is equal to about negative 0.4. Lastly, we know that our tangent value is the same as our y value over our x value. So tangent is going to be equal to 0.9 over negative 0.4, which gives us a value of about negative 2.25. So now let's look at point B. Point B is at an angle of 217 degrees. Again, let's draw straight lines to my x and my y values so that we can see it better. So let's go straight up to my x value and go straight over to my y value. Okay, this gives me an x value of negative 0.8, and it gives me a y value of negative 0.6. So we can go over here to my table I created. My y value I said was sine, and that is equal to negative 0.6. My x value is cosine, is negative 0.8, and my tangent value is y over x, which is negative 0.6 over negative 0.8, which gives us a value of positive 0.75. Now you try point C. As always, pause the video if you need more time. So hopefully you got these values here. Sine of the angle is equal to about negative 0.49, cosine as 0.86, and the tangent value of negative 0.57, or very close. I know it's hard to tell on the screen here, but hopefully you got answers that are very close to these. We know that the x and y coordinates can be positive or negative depending on the location in the coordinate plane. The positive and negative values of the trig ratios can change according to which quadrant the angle is in too. In quadrant 1, all values are positive because the x and y values are positive. In quadrant 2, the x value is now negative, but our y value is still positive. This means that the sine value is positive, but the cosine and tangent are negative. In quadrant 3, the x value and the y value are now negative. Because of this, the sine and cosine are both negative, but the tangent is positive. Remember, tangent equals sine over cosine. Negative over a negative is a positive. In quadrant 4, the y value is now negative, but our x value is positive. This means that the cosine value is positive, but the sine and tangent are negative. Looking at these examples, let's try to determine if the values are positive or negative. Thinking about the explanation we just had about which values are positive and negative in each quadrant, let's quickly write that down so that we have a quick reference to which is positive and negative. So let's look at my first example here, cosine 98 degrees. We need to determine which quadrant this angle would be in. Well, we know that here is 90 degrees and here is 180, and 98 would be somewhere between there, so this is in quadrant 2. And cosine, we know in quadrant 2 is a negative, and cosine, we know in quadrant 2 is a negative value. Next up, let's look at tangent of 245 degrees. Again, we need to determine which quadrant 245 degrees is in, and we know 245 is more than 180, but less than 270, so we are in quadrant 3. Tangent, we know, has a positive value in quadrant 3. So go ahead and try sine 318 degrees. Pause the video if you need more time. So we know that 318 degrees is in quadrant 4. And we know that sine in quadrant 4 has a negative value. In trigonometry, there are some special angles that we like to use. These angles include 0 degrees, 30 degrees, 45 degrees, 60, and 90 degrees. This animation will help you understand how we get these angles and the lengths of the sides we use for the trig ratios. We start with an equilateral triangle with side lengths of 2. Because it's equilateral, we know that the angles are all 60 degrees. We then divide the triangle in half. This creates a right triangle with 30 degrees and 60 degrees. Our hypotenuse stays at 2 units, whereas one of our legs becomes 1. The other side can be found by using the Pythagorean theorem, a squared plus b squared equals c squared, and we get the square root of 3. Our 45-degree angles comes from an isosceles right triangle with sides of 1, 1, and square root of 2. Because it's isosceles with the right angle between the equal sides, the other two angles are equal to 45 degrees. In this example, we want to find all of the sine, cosine, and tan values of our special angles that we just saw in the previous animation. So I've already got our special triangles drawn here at the bottom. I've also got quadrant 1 of the unit circle with the special angles on it. So let's first look at sine. Let's look at sine 0 degrees. We know 0 degrees means that it is on the x-axis, and we know sine is our y value. Well, if we are on the x-axis, that means our y value is 0. So sine 0 degrees is equal to 0. Let's try sine 30 degrees. Well, for that, we need to look down into our special triangle of our 30, 60, 90 triangle, and we know sine is opposite over hypotenuse. So opposite of the 30 degrees is 1, and our hypotenuse is 2. So sine 30 is equal to 1/2. Let's move on to 45 degrees. Sine 45, we'll look in our second triangle here. Again, sine is opposite over hypotenuse, and our opposite is 1, and our hypotenuse is square root 2. Sine 60 degrees, look back at our first triangle, opposite over hypotenuse. The opposite of 60 is square root 3, and the hypotenuse is always going to be 2 in this example. And last, sine of 90 degrees. 90 degrees is on the y-axis, and sine is our y value, and because our unit circle is always 1 unit long, we know that sine of 90 is equal to 1. Now we need to find cosine and tangent. So you try this one here. Find cosine and tangent of theta for each of the special angles. Be sure to use our phrase SOHCAHTOA to help remember which sides go with which ratio. Pause the video so you can fill out the rest of this table and find the answers. So hopefully you got these answers here. One thing to note here is that when we're finding tangent of 90 degrees, if we do the ratio of sine over cosine, you get 1 over 0. Remember that we cannot divide by 0. So if you have to divide by 0 in this situation, your answer will be undefined. So there actually is no answer for tangent of 90 degrees. Well, that's it for today's lesson about the unit circle. Remember, if you need more practice, please download the worksheet from the link in the description. Come back next time for our next lesson. Have a good day. Bye.